Hello everyone, and welcome to the last function we need to write for our model. So the last function is the getServedTFExamples function. So wouldn't it be nice if we could save the transformations that we did in TFX transform as part of our model? So if you could save these transformations as part of your model, meaning when you get a new input, you don't need to do these transformations before using the model to predict your output, right? So that is what this function does. It saves the transformations that we did in the transform as part of some transformation graph and then attaches it to the model so that we can just use the model directly, and TFX will take care of calling these transformations for us. So let's just go ahead and then write this get serve TF examples function, right? So I'm just going to put that just here, and you'll see the reason why I'm putting it just before the run function. So I'm just going to say get serve TF examples model TF transform output, right? So the getTF examples function will take two inputs, the model and then the transformation function that we wrote in TF examples, right? And then we would save the transformation functions or the transformation features as part of our model. So this is how we do it. We just say model.tft layer. So model.tensorflow transform layer is equal to tf transform dot transform features is transform features layer, right? And then um, after this we are going to write another function that would take our TF examples, right? So we will write another function that will just take our TF examples and then perform some transformations, right? So what this getServedTF example function does is just to take our input and then perform our transformations using um, our saved transformation features. So I'm just going to decorate this function with the TF example, with a TF function. So this is a function decorator. It will add this function to the TensorFlow graph. So I'll say serve TF examples, and then the input is serialized TF examples, right? And then I need to specify um, the feature specification, right? So I'll say feature spec. So tf transform output dot raw feature spec. So what this does is the tf transform output dot raw feature spec is what type of feature specification do we need, right? What type of feature specification are we passing? So the feature specification for transform. So as I told you, we are working with TF records. So it's a TF example, right? So our feature specification is a TF example, meaning that whatever inputs we pass here should be a TF example. So this is serving as sort of a check. So if we don't get a TF example, the code would not run. If our input we are passing is not a TF example, the code will not run, right? One thing that we also have to do is that we have to remove um, the the serving label, right? So because when we are performing predictions, we don't have an output. We only pass in input. So we only pass in reviews or things like that, right? We don't have an output. So we have to remove the the feature the labels, right? So I'm just going to say feature spec dot pop, right? And then we have to go up here. So our label was what? Rating, right? So we have to put in label here to be rating. So this is raw feature spec, raw feature spec. So we have to not the transform but the raw one, right? Then the next thing we have to do is we have to now pass the we have to parse the TF examples, right? So into a dictionary of tensors. So parsed like we did um, here. So we pass from string. So something like that. So this is parsed features. And then we get tf.io dot parse example, and then the input is serialized TF examples feature spec. And then after doing that, we just have to transform the raw examples using our features. So we say transformed features is equal to model dot tft layer parsed features, right? And then we return model transformed features. Okay, so yeah, yeah, well, I think this is it. So this will when we say model transform features, this will get predictions, right? Get predictions using the transformed features. So doing this will give you the predictions of using the transform features, right? So now what do we do with this get serve TF examples? So what we have to now do is to use it in our run function, right? We have to use it in our run function. Before we can use it in our run function, we have to specify something called a signature, right? So the signatures is like what kind of transformation do you need to perform when you call your model.predict, right? So something like that. Do you need to perform some transformations? Do you need to do something before the model actually uses the inputs to predict something? Or yeah, some kind of transformation or some kind of processing or something like that. So we're going to name our, because this is a dictionary, so we need a key we are going to call our signature serving default, right? And this serving default should call the getServe TF examples function, right? So yeah, that's what it does. So it will call this getServe TF examples function, and then the getServe TF examples function expects a model. So it expects an input of model, and then so I realized I just made a mistake in the serve TF example. So if you realize, we are never calling serve TF examples. So what we have to do is we have to return serve TF examples. Sorry, it has to be function. I should name here function so that I know that it's a function. So we return, so that when we return this serve TF example function, it calls this function over here, and then yeah, that's it. That's it. All right. So let's continue writing our serving default. So as I said, it takes in two input, which is our model, and then it takes in the TF transform output also, and then um, it needs to have some tensor specifications, right? So I'm going to say dot get concrete function. So tf dot tensor specification shape is none, d type is tf dot string, and the name is equal to examples, right? So this is how we define our seven signature, right? It's probably the same for mostly any type of seven signature you would ever define. So you just have to know the syntax of how you can define a seven signature. It's the same everywhere at a time. And then we go to model.save. So we say function argument dot seven model directory. Our save format is equal to TF, and then our signatures is equal to signatures, right? Hopefully there is no error um, for this, but if there is an error, we would work on it. Yep. So let me run this thing, and then run this, and then let's see for a few, let's wait for 1 or 2 minutes to see if it will run, and then we would see what else to do. And there is one important thing I haven't talked about. So I don't know if you have wondered about this. So you know that anytime if I want to run the trainer function in my Jupyter notebook, then I need to have the transform function already run. I need to have the schema function. But if I have already run it, and let's say I close my Jupyter notebooks, do I have to run schema gen again? Do I have to run transform again? Do I have to do that? So you do not have to do that. There is another component called the importer node, which can just directly call locate whatever folder or whatever output you are looking for, and then you can just use it in your component without you calling that component or running that component again. So we'll look at the importer node, with the importer node before we go on to um, our next component in our pipeline, which is the evaluator and then the resolver node. So I'm just gonna, let's see. Okay, so I'm just gonna pause this video and then let it run. Hopefully there is no error. But if there is an error, I will just fix it and then show you what to do in our next video. Oh, so just keep. So I'm just going to pause it now and then come back when it has finished running. Okay, so it has finished running. I made some changes to the code. So instead of having the model run through all the data for every epoch, I put here steps per epoch and validation steps. So it's only so when it sees about 1,000 samples of the data, it just says that the epoch is done. So as you can see here, out of 1,000, right? So yeah, that will make it train faster, because you're not training on all the data sets at once, but subsets of the data sets at every epoch, right? Okay, so we are done with the training. Just ignore the warnings and all that. And so we can go to our folder to see where, yeah, so let's go to our folder and then check our pipeline. So we can say our trainer here, our model. So this is, yeah, so this is these are our models that have been saved, um, yeah, for us. Um, Before we go to our next video, I want to um, talk about, or let's talk about something else in our next video. All right, so see you in the next video.